Welcome to another video. Have you ever wondered what happens to our typical equation of a straight line, y equals mx plus b, or the equation of a parabola, which is y equals x squared, or the equation of a circle, x squared plus y squared equals r squared, everything centered at 0? What about the equation of an ellipse? You know, the standard equation that we know, x squared over a squared plus y squared over b squared equals 1. What happens to all these standard equations if we rotate our graph? I mean, we rotate the x-axis, we rotate the y-axis so that what used to be vertical and horizontal becomes inclined. Will we maintain the same equations, or do we have to make modifications? Well, if you change the foundation, everything changes. And that's what I'm going to explain in this video, because we're going to assume a theta rotation of the x-axis and the y-axis so that this goes from here to here and this goes from here to here. And what does our typical equation become? Let's get into the video. I decided to do a general explanation of what happens when our typical shape does not stay where we want it to stay. Instead of me picking the ellipse and explaining it, I'll just explain a general rule that you apply to whatever function or equation that you're working with. And all we have to do is change what our x is and change what our y is. Okay, now, typically, if I say x equals 5, for example, I just want to use this to explain. If I choose a point 5, -3, all I am saying is if I travel horizontally, this point is 5 units away from 0 if I travel horizontally. And if I travel vertically, it is 3 units away from 0. Going down. This one goes right, this goes down. So anything here is purely x, purely x. This is purely y. No part of this goes up. It is x equals 5. You just travel horizontally. But once you start inclining the axes, nothing is pure. There is now a combination or an interaction between the x and the y-axis. Because look at this line. This line has gone both up and it has also gone to the right. So assuming I pick a point here. If I pick a point here, I call this point, let's call it x prime, y prime. It does not mean you have traveled x prime units to the right. That's not true. It means you have gone x prime units along this line. It does not mean that's how far you have gone horizontally. And this is why we have to make some adjustments. So how much of this distance is purely x? How much of this distance is purely vertical? We have to resolve this middle line into its component, both the horizontal and vertical. And that's the only thing you need to know, and every other thing will adjust itself. So let's look at this. Suppose we have this. This is supposed to go straight like this, but no, we stop here and we call this point x prime, y prime. You see, we can make this a right triangle. We just want to know what portion of this x is purely horizontal. Okay, so let's say this is going to be our x, but this is our x prime. The portion of it, we don't know what it is, but it's x prime. If this angle is theta, we know that the cosine of this angle is this divided by this adjacent over hypotenuse. Remember, this is how far x goes along this fake or rotated x-axis, right? We call it the x prime axis. So we can say that cosine theta is equal to x from here to here divided by from here to here, which is the hypotenuse, which is going to be x prime. So we know that x equals x prime cosine theta. Right? And similarly, since this angle is theta, this angle is 90 minus theta, this one here. We want to know what portion of this length has helped the y-axis. Normally, a pure x does not help y because it doesn't rise, it stays flat. But this one has both moved to the right and risen. So there has to be a component of the x prime that is also helping y to go up. So what portion of this is y? It's going to be x prime sine theta. Remember, cosine 90 minus theta is the same thing as sine theta. That's basic trig, okay? So we also know that so this is the horizontal portion, horizontal. And then you have x equals x prime. Sine theta is the vertical portion. So this has both the horizontal and the vertical portion. And remember, in our basic Cartesian graphing system, all we deal with are horizontal or vertical. It's either going to the right or to the left, or it's going up or down. That's how we read the graph. And so that's all we want. What part of this is vertical? Boom. What part of this is horizontal? Boom. The first part. That's it. So we are done with whatever this theta rotation has done to our x. Now, let's go to our y. For the y, we still have to say what portion. Notice that this y is not purely y. It is affecting the horizontal. In fact, it is fighting against the positive. It is now dragging itself in this direction. Or it is still going up. So this is going still up or going in the opposite direction of this. But we can do the math. All we have to say is what portion of this y is affecting the x-axis. Well, it is this same y prime times the cosine of the angle, just as we did it here. But the angle between y and the x-axis is now theta plus 90. See, this angle here is 90 degrees. So it's going to be theta plus 90 degrees. So we say y will be equal to y prime times the cosine of 90 plus theta. That is the horizontal portion. From here all the way to x. And the vertical portion is just from here to here, which is theta. Remember, when you move your graph, if this goes up by 30, this goes this way by, not 30, by theta, this also goes up by theta. So here, y equals y prime. What portion of this is here? It's going to be cosine. Cosine theta. Okay, and that is the vertical portion. So I could have written this in cosine form, but we know that cosine of 90 minus theta is sine theta. That's why I just left it that way. So, and this is all you need to know. So what we have is, we say what portion of this is horizontal, what portion is vertical, and that's it. That's all you need to understand. Okay, I just noticed that everything else looks clean except this one. This one has the double angle. We can't do the double angle with just one theta. We don't want cosine 90 plus theta. That looks weird. So let's quickly go back to our trig identities and resolve what cosine 90 minus theta is. So using the angle sum identity, we know that cosine 90 plus theta should be equal to cosine 90 cosine theta minus sine 90 sine theta. Cosine 90 is 0, so 0 times anything is 0. So this is basically 0 minus sine 90 is 1 times sine theta. So this expression is actually equal to negative sine theta. Okay, so the total original y-axis component, which is the vertical component, let's do the horizontal first. The total horizontal component of this rotated axis will be everything horizontal, this plus this. Oh, it's going to be x prime cosine theta minus y prime sine theta. Because this now is going to be, so we can put the total there. So we have horizontal, here we have vertical. So here we have the total horizontal component is going to be this plus this. It's going to be x cosine theta. The other horizontal one is minus y prime sine theta. That is the total horizontal component. Remember, this is the same thing as this. Okay, this cosine. And then for the vertical, it's going to be y cosine theta plus x sine theta. So it's going to be x sine theta plus y cosine theta. Prime, sorry. It's prime. Nice. I would have loved to switch the positions of y and cosine so you know this is the horizontal portion and that is the vertical portion, and it is sine if it is the other one. It's easy to see. That's it. So as long as you know what theta is, we can write the equation of anything. Oh, now let's take one example and then you'll see how to use this. Okay, I have a very basic example here. Suppose you're given the linear function y equals x plus 4 on a regular graph. Now what happens when we rotate the axes? It's not going to keep the same equation. It's going to be a different line in the new system. Okay, how do we do that? All we have to do is change our x to this and change our y to this, and it's been rotated through 45 degrees. Now, is it clockwise or counterclockwise? Always know that rotation in math, unless otherwise specified, is always counterclockwise. We'll always go this way. Okay, we'll always go counterclockwise. So that's the angle of rotation. We're going this way. If you go this way, it would be the negative of it. And by the way, you might get a question that says, what happens if we return this graph this way? Well, it means you're going 45 degrees counterclockwise. We just have to change the angle computation, and it's easy. I don't want to mix this with matrices, but just understand that you just go the opposite direction, and what happens is this negative y prime becomes positive y prime, and this positive x prime becomes negative x prime. Not x prime, will be x now. So you'll be going from the primes to the regular x. Okay, maybe I'll write the formula later, but let's just do this. So basically, looking at what we have, we know that this equation, based on what we have seen, will be equal to y. What is our y? That's y prime cosine 45 degrees. So we have y prime cosine 45 plus x prime sine 45 plus x prime sine 45 will be equal to x plus 4. X prime cosine 45 minus y prime sine 45. I won't have enough space to write it, so I might just evaluate the cosines. Okay, we know that cosine 45 is rad 2 over 2, sine 45 is rad 2 over 2. So I think it will make it thinner. Okay, So going by our formula, we're going to have y prime times rad 2 over 2. And both of them will have rad 2 over 2 actually, because this also is rad 2 over 2, sine 45 degrees. So it's going to be y prime plus x prime times rad 2 over 2. So it's going to be rad 2 over 2 times y prime plus x prime. That's what this becomes. And on the other side, it's going to be the same thing, rad 2 over 2, but it's going to be here, x prime minus y prime. X prime minus y prime. And that will be added to 4. Remember, we're trying to find a new equation. And typically, when you write the equation of a system, you put y first before you write x. But now everything is mixed up. So let's distribute everything and see, oh, wait. Let's get rid of the 2's. I'm going to multiply everybody by 2. So we can get rid of the fractions. So let's multiply everything by 2. We end up with rad 2 y prime plus rad 2 x prime equals rad 2 x prime minus rad 2 y prime. Because we've multiplied by 2, this would be plus 8. And then notice how you have rad 2 x prime on both sides. We can cancel them out. Cha, cha. And we can move this here so that you have rad 2 plus rad 2, which is going to be 2 rad 2 y prime will be equal to 8. So you divide both sides by 2 rad 2, so y prime will be equal to 8 over 2 rad 2, which when simplified is going to be 4 rad 2 over 2, which is 2 rad 2. 2 rad 2. So the equation that we read as y equals x plus 4 in our normal x and y axes, or a platform or graphing system, will eventually, when you rotate it, become the line y prime equals 2 rad 2. So it's going to be, in this tilted graph, it's going to be a horizontal line. And that line is going to pass through the point 2 rad 2 in the new line. So in the new line, the old graph, which was supposed to go through, let's say we call this 1, 2, 3, 4. That's too much. Let's see. 1, 2, 3, 4. So the line y equals x plus 4 would be a line that goes this way. But it already looks like it's going to be a horizontal line in this new rotated system. Yeah, it's going to be a horizontal line. It's going to be something that goes this way. Well, I didn't scale this correctly, but that's what you're going to see. You see the picture? Yeah, I'd like to just make it look good, but my skill is not that great. Let's just say we do something like that. So we're going to have a graph that goes somehow like this, like a horizontal line. This is not a horizontal, that's terrible, but that's the picture. The same thing you do if I gave you an ellipse. Just do all your math, you simplify. The new equations are going to be in terms of x prime and y prime. And if you're going in the opposite direction, it's going to be this exact same thing. Let's say you're converting from the new system to the old original system. All you have to tell yourself is, and then I'll end this video. Okay, so we know that since this is x being this, we know x prime will be equal to x cosine theta plus y sine theta. But when we want to write y prime, this sign is going, this sign has changed to plus. Now this sign is going to change to minus, and that's it. Y prime will be equal to y cosine theta minus x sine theta. I hope I got that right. This is correct. So this is how this works. Just understand the whole work you need to do is this. Let me make this clean. So this makes it very easy to remember. They are very, look, what you have here is what you have here. It's just that the sign changes to a minus. What you have here is what you have here. It's just that the sign changes to a minus. Everything else is the same. The cosines come before the sines. And whatever you write here is what starts. Whatever you write here is what starts. What you write here starts. What you write here starts. Never stop learning. Those who stop learning, stop living. Bye-bye.